Hello everyone. The target of this Recordant MFBD kit is the ones who are not familiar with Recordant MFBD technology. The purpose of this Recordant MFBD kit is to introduce the basic information about how to use toolkits related to Recordant MFBD. If you have never used any of Recordant MFBD toolkits, I recommend you watch this lecture in order from the beginning. Overview of MFBD, full flex, R-flex, then post-analysis. First, let me talk about the overview of MFBD. MFBD is an abbreviation of multi-flexible body dynamics, or flexible multi-body dynamics. MFBD is a technology to analyze the dynamic behavior of a system, which includes both rigid bodies and flexible bodies using multi-body dynamics and finite element method. As you see, the entire system or only a specific body can be used as a flexible body. Therefore, it is possible to simulate the dynamic behavior of a system, including both rigid and flexible bodies efficiently. MFBD has the following benefits. First, it is possible to change specific bodies to flexible bodies for dynamic analysis. Of course, you can easily convert a flexible body to a rigid body too. Second, it is also possible to easily replace the existing rigid body with the mesh data that was previously created by FEA software. Third, you can check the stress, strain, and deformation acting on the flexible body due to its dynamic behavior. Boundary conditions are naturally applied to a flexible body through motion, force, constraint, contact, and so forth. As you see, if you simulate a model after converting a rigid body to a flexible body, not only the position, velocity, acceleration, but also the strain, stress, and deformation are calculated. Then, why is MFBD needed? MFBD is based on the rigid multibody dynamics. Multibody dynamics can simulate the behavior of a system composed of rigid bodies and also calculate joint loads or driving force and torque. Based on this, the extended version can be MFBD. MFBD allows to simulate the stress applied to the part, evaluate the durability, and analyze the behavior of the system, considering the deformation of the part. The example video on the left below is a model consisting of a drivetrain shift fork as a flexible body. It is possible to calculate the stress generated in this shift fork and even perform durability evaluation. And the example on the right is a manipulator. When the manipulator operates, the end tip actually vibrates excessively, so it needs to be controlled to reduce the vibration. Only with rigid bodies, these vibrations are not expressed accurately. The vibration caused by deformation can be expressed when the system is composed of flexible bodies. This MFBD can be classified into two categories. The first one is nodal method using a full flexible body. With this nodal method, it is possible to perform a nonlinear analysis in consideration of the degrees of freedom of all nodes of the flexible body. Nonlinear analysis includes geometric nonlinearity such as large deformation of hoses, material nonlinearity such as plastic materials, and boundary nonlinearity with the contact or varying load points. The second is modal method using a reduced flexible body. The modal method utilizes the mode shapes calculated from the modal analysis of a flexible body. The modal method performs the simulation based on the assumption that deformation of the flexible body is linear by applying modes per position. The modal method is suitable for the cases where the deformation is small and when the loading point do not change. There are three types of bodies in Recordine: rigid body, full flex body, and R-flex body. Full flex body and R-flex body are flexible bodies. When fast simulation is necessary or body deformation is negligible, using a rigid body is good enough. If a body contacts another body or nonlinear characteristics need to be considered, full flex body must be used. If the deformation is small or fast calculation is necessary while considering flexibility, the R-flex body can be used. There are several kinds of features for MFBD. The following are its main features. First, Messier converts a rigid body to a flexible body for MFBD. F-flex runs simulation using nodal method. R-flex is a modal method-based flexible body simulation feature. In order to create a R-flex body, modal analysis must be performed. R-flex-gen runs modal analysis in Recordine environment to create a R-flex body. Durability is a fatigue analysis toolkit using MFBD simulation results to predict the fatigue and life. And these are the brief differences between full flex and R-flex. Simply speaking, accuracy is important with full flex and speed is important with R-flex. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.